Hey everyone, how are you all? So in this stream, we are going to build this game hand cricket. So for now, the rules of this game are irrelevant because it is basically we are basically trying to create a hand gesture model for now. So that's what we are focusing on at the moment. And since last two streams, I have been collecting data of different hand gestures, and actually not different hand gestures. I found uh, so we need almost, let's see, 7 gestures. So I collected 6 from a single data set from Kaggle. This data set fingers contains 6 of the 7 gestures that we need. And for this thumb gesture I had to get another data set, this one, and gesture recognition database. So this data set contains the thumb gesture, and I tried to download both of this and merge all of them together, merge both of this data set together. And I had to modify the labels because these two data sets are labeled differently. This data set contained the label inside the image file name, and this data set uh, contained the label in the on the parent folder. So for this the parent folder name was the label basically, and I had to download this whole data set and zip it, unzip it, and upload it to Google Drive. So that took a lot of time because, and also I had to sync the Google Drive data with Google Colab. So it almost took two streams to prepare the data set. So finally we are done with getting the data set, and in this stream we are going to build the model to use these data sets that we have downloaded. So I have already installed the FastAI library. Okay, so that's another thing. I will be referencing the FastAI material because I'm doing this course, and this project is basically for uh, in support of this course only. So I'm only implementing the things that I'm learning in this course, and it will be about transfer learning. So let me import it then. Let's see, we are going to use this pet breeds. Let me import the first book. All right, the library has been imported. Now let's see, we have to get the data block. For that, first I have to get the path to the data set that we have done. Or let me check if I have the data set or not. So it should be there because I have almost wasted a lot of time collecting the data set. Okay, this is the one I'm talking about, fingers, and we are only going to use the training data set. We are not going to touch the test data set because the training data set contains enough images that we can use to train our whole model. I think it contains almost 20,000 images. Let me check. So test dataset contains 3600 and training dataset contains almost 18,000 plus the thumb images that I merged into this dataset. So that will amount to almost 20,000 images, and out of those 20,000 images also I'm going to use a subset, because if I use all of this 20,000 images, it will definitely crash the Google Colab. So I will use subset. So let me get the path to this folder. Why is it not showing us the files? I hope it contains the images, because I have wasted a lot of time collecting the data and uploading it to Google Drive. Let me check it if it is inside the Google Drive or not. Alright, I have all the images inside my Google Drive, so it will be alright. It's just that this UI is not showing us the images. It is alright. So I have copied the path. Let me get it. It's the path variable now. I can select the path as the base path. So now we can list all the files inside the path. Oops, string objects has no attribute. Does it? Okay, I have to pass this thing inside a path object. Now it will have ls function or whatever it is. So now I have all the images. There are almost 20,000. There are 20,000 images, not almost 20,000, exactly 20,000 images. So now that we have all the images, let's create a data block. So for that, first of all, let me hide all of this. It's going to take a lot of skill in real estate. So is it hide code? Yes. I don't only need to hide code. I want to what the hell happened? You know what? I'm just gonna get rid of, maybe not. Let's just give them and okay, why did it collapsed into a half column? Damn. I can't even undo it. Okay, let's leave those. We will continue with getting the data block. So we will place this data block inside, let's say, just get the data block object. First we will get the blocks. The first one will be image block. Second one will be category block, because we are going to categorize the images. And we're going to get items. So those are all image files. Therefore we are going to use get image files function, right? And run splitter. So this is where we will use a splitter. We will be using a subset splitter. So let me check the FastAI docs, FastAI subset splitter. Subset random subset splitter. Yeah, I guess this is the one, random subset splitter. So let's use random subset splitter, and we will have to pass a training data set size and a validation data set. So let's select point 1 for training size and point yes, point 02 or something for validation size, and seed will be well. For now let's not keep the seed argument, and after that we need to get, let's reference it again, we need to get the get y. So get y is basically the dependent variable or the label, and the labels are inside the file name, so we can use this function only, the same function using attribute, and we can pass a regex labeler. Now to this regex labeler we have to provide a regex. So let's see what we need to extract out of those images. Now this images contains label on the last, so we need to extract this character 0 on the, so on this number, sorry. So we have to get the last second before the dot and the last underscore, whatever is after the last underscore. So let's see how we can do that. Where did it go? So here Okay, they have this kind of label, this kind of file name, and they need to get this label. While in our case we need to get this last thing after the underscore. So they will use this kind of regex. Let me reference regex, Python regex. Let's first experiment with getting a single label. So, well, the label is inside. I can directly get the first. Let's check if fname contains the first name or not. All right, we have first object, so we'll experiment with getting this first. re dot find all fname dot name. So let's see what it gives us as back. Nothing basically, and I think almost all of them are png or something. There might be jpegs as well, so we shouldn't assume all of them are png. So this braces capture group, capture and group. Dot is for all the characters, it matches everything, any character except new line, and plus is for, let's say, one or more occurrences. So one or more occurrences of anything until you hit underscore. Wait, but go back to the notebook. So this will match all of this until you hit an underscore and a number dash d slash d. Backward slash d is for digits, and plus again for one or more occurrences. So this will match this dot jpeg until we hit this. So this will select all of this. So in our case we need to select this 6L. So let's see how we can do that. So we need to get up to last, anything matching up to last underscore, we need to get rid of it and only get this character. So let's see what we can use. Capture and group. So let me remove capture and group. So dot one or more occurrences of anything until we hit an underscore and a digit, and we won't be having double digits, and we can place the capture group over in this portion, and we can again say dot, well, this dot will match dot, and I can say star. So let's see what it returns us. All right, it returns us underscore, so we can get rid of this underscore and place it over here. Now we will be getting the correct label. All right, we have got the label now, so we can use this regular expression inside this regex. Let me copy this. We have a working regex now. Now we need to pass the name thing over here, name, to second parameter of using attribute. After that we need to apply item transforms. Well, let's not apply the transforms right now. Let's just first check if we are getting correct data sets or not. Okay, so I've got the data block now. Now let's get data set just dot data sets. This will give us back training and test data sets inside dset variable. So we can use dset.train to check the training data set. Is it saying it has no? Why does it? Let's see what attributes we have then. Dset dot all right, we have to pass the path as well, so that's the bug. So we will pass the path variable over here. Now we will have the training data set. So as you can see, we have got 2000 images in training data set because we have selected only 0.1% of the whole data set, and all of them are converted to 120. So most of them are 128 by 128. This fingers data set contained all of the images inside this data sets are 128 by 128 pixels. So there's that. Wait, is my internet connection working correctly? Which is showing me that the connection is unstable. Well, my internet is correct, working correctly. Why is it showing me that I have an unstable connection? Now even YouTube is not getting enough data, although my internet connection is working all right. Even OBS is showing me perfect statistics. Why the streaming platforms are not working? Let me check. If any of you guys are watching right now, please let me know if the streaming is coming to you correctly or not. Like, are there any lags or something? Because the Twitch and YouTube streams are showing me that I'm not sending enough data. Please, if any of you are watching, just let me know in the comment section if you can hear me or you can see the screen or not. Well, the Twitch inspector is showing me that the stream is stable. Then why is the stream manager showing me? And it shows me no delays are there. Even my internet connection is all right. Mhm. All right, it is showing now that the stream is excellent. So now I can continue with my work. Let me check YouTube streaming as well. YouTube still says that it is not receiving enough data. Well, it's alright. At least Twitch is showing me that it is receiving the data, so I'm gonna continue. So let's see, where was I? I was saying that we have 2000 images inside training dataset, which is enough for now, or maybe we will have to cut this down as well because it might take a lot of time. And this dataset contains a tuple, a list of tuples. A tuples contain images as the first element and a tensor of category as the second element. And most of them are 128 by 128 images, but the thumb images will be they are not perfectly sized like most so we will have to apply the transforms. Let's also check validation dataset. So it should be might be inside, let's say valid. So validation dataset contains 400 images. can also check the vocab. This will give us all the labels. Dset is okay. It's not dset, it is just dset. So these are the labels that we are going to classify as 0, 1, 2, 3, 4 and 5, 6. Are the labels that we are going to classify as 0, 1. Sorry for the feedback, guys. I was just checking if my internet connection or if my stream is streaming correctly to the YouTube or not. Okay, it seems perfect. Let me continue then. So now we have to use item transforms. So in this case, let's see which item transform we can use. Well, I can just get this randomized resize crop for now. Let's see how it performs. So let's get that item transform randomize, and we will be resizing all of them to 128 by 128. And by the way, most of these images are 128 by 128, so they won't be cropped, but the thumb images will be cropped to 128 by 128. We can also reduce this down so that we'll get a variation of these images as well, which are 128. But for now, let's just keep it as 128. Minimum scale, it doesn't matter, we will tweak it later. Let's get this data block, and now we can get the data loaders inside the ELS. Just dot data loaders, and we have to pass the path. Let me check summary. This will give us what this data block API is doing to the data. First, we are collecting 2000 items from this folder. Then using the random subset splitter, we are getting 2000 and 4000 images separately. After that, we are categorizing those images starting from one image, getting this image and creating this kind of fill image data, whatever it is. After that, applying the categorize, which gives us this second element of the tuple, which is the dependent variable. After applying this two steps, we get this kind of tuple. Same, we apply, we get different batch of this kind of tuples. And let's see where the transformation is being applied. Randomized research crop. So the transformation is applied after we have got one batch, or maybe it is before getting the batch, because this is item transform. We are applying the item transform. We are not using the batch transform for now. Let's quickly check the images as well inside one batch. So batch, I can use this code. Why Why is it giving us error? So batch is not inside DLS. Maybe I have not got, but I did get the data loaders. Still it is not giving me so batch. Why? What's the problem? Well, there was no error when I tried to create this summary. Also, when I try to create the data loaders, then why is it giving me error now? Did I make a typo or something? Which doesn't seem to be the case because I have just copied the code from here. Let me check what attributes we have inside data loaders. Why do we not have so batch? What is inside subset then? Let's take 0. So it's just the subset that we took using random subset splitter. That's not what we want. We need this kind of functionality. So batch. Why can't I fire this command? So batch. Let's see if I'm making any mistake or something. First I got to the data block. After that I also got the data loaders using the path. And let me get the data loaders again. Now let's fire up this command. Let's search for this error. Well, I have constructed a data loader. Then also it is not giving me so batch. Okay, let me use so batch without this arguments. Does that mean that I'm not getting? Oh, wait. We are not getting the data loaders. We are getting the data sets. So that's the issue. Now it will work. Wait, is it going to show us the whole batch? We don't need whole batch right now. Just show us one row. It is taking this much time to just to show us this batch. Just imagine how much time it will take to train the model. Right? The data seems cool, right? I also need to pass. I want to check most. I want to display all images from each category. So let's see. So use unique. Well, it will just show us an image from just one category. Let me use 6 inside here and 2 rows. Let's just hope it can wait. I have to get rid of this comma. I just want to check that if we have correct thumb images or not. So yeah, this thumb image doesn't look that much different from all of the other images, so that's good. The background is just a little bit black, but it doesn't matter because in the application we are going to use grayscale image, so that will be all right. So since we have correct data, now let's try to use the model. We can directly train the model now. We can get the learners, learner. We can pass the data loaders, and let's not use resonate 34, let's just use resonate 18. Matrix will keep error rate for now. Let's fine tune it for 2 epochs. It's going to take some time because we have 2000 images inside the training set, plus 400 images inside the validation set. So we have to further cut it down because, as you can see, it is taking much time for even for the first epoch. This image has been cut off, like we can't see the one. Why is that the case? Is it because of the transform that we applied, or the images like that inside the data set only? Because this is going to cause problem, I guess. We'll see later, because we have not tweaked the transformation and anything at all. We're just checking how our model performs without any tweaking. It's just the basic default stuff. is done training. So we are getting 0.78 error rate. We have not fixed, so but the training loss got down up to 0.09, but the validation loss remained at 2.61. So that's a clear sign that we are overfitting it. So let's see what we can tweak now. First of all, I'm going to reduce the size of the data set. So this time I'm going to use, so 0.1% gives us 2000 images. Maybe we can use, let's say 500 or something. So let's use 0.05%. Excuse me. And 0.01%. Let's see how many images it gets us. So 0.05 and 0.01 gives us 1000 images for training and 200 for the test. That will half the training time. So let's try to use the new subset now. Let's see how much time it takes. It is definitely training a lot faster this time. So this much time is all right for the experimentation. So now we can try to improve this model. So let's see what we can do now. So we are using random resize crop. We can use precising at this step. So let me show you what it looks like, the precising transformation. This is what precising does. Crops some part and then again crops another part of that cropped part and applies the transformation. So we get this kind of image. So let's use the precising step. This is how we can apply that precising. We can resize it to 128 by 128. So in our case we will, let's see, we can reduce it to 64 maybe. That will be alright, right? We can resize to 64, then apply the augmentation transform. But it will further reduce it down. So let's just keep resize to 128 only, and we'll see. By the way, let's check the what is it called, confusion matrix. Let's check the confusion matrix of our model, this model, see what it looks like. It's the code. Let's see. And let me try to type it so that I can remember the code. It is inside classification interpretation from learner. You can pass the learner here. dot plot confusion matrix. Figure size, yeah, 12 by 12 is all right. DPI 60. This will show us, wait, what happened? Okay, place the dot over here. Oof, the results definitely don't look very much good. So ideally we should have this kind of diagonal line, but it is showing us straight lines, so definitely the model is not working. So all of these images are classified as either 2, 4 or 6, and our model is ignoring all this 0, 1 and 3, 5. So what might be the case? Let's plot the most confused. Not the most confused, we want to check the log images which are most confused. So we can use, let's say, it's inside plot top losses. Yes, we can pass k, show us 10 top losses. So these threes are classified as 2. Why that might be the case? Let's further check. So most of the losses are for threes. Is that the case? Let me see the confused classes. 1 and 2 are confused, 3 and 2, 0 and 2, 5 and 2. So most of the images are confused as 2s, and these 5s are confused as 4. So let me check what does 2 look like. So this is how 2 looks, and 1, 3, 1, 3 and 0. This is 0. All of them are classified as 2. So it may be the problem with, let's see, it may be because of the transformation step. This is what we get after applying the transformation. Where are the tools? There are no tools. Let me check some more images. 4. Why is it showing me only this much images? Do I have to? What if I increase this to 8? Okay. So it just modifies the rows and columns, but it doesn't give us more images. Alright, we'll see what other things we can do, because our model definitely doesn't look like it is working. Let's tweak the transformation first. We are using randomize resize crop to 128 by 128, but most of the images are 128 by 128. So let's check the source code of this function. Picks a random scaled crop of an image and resize it to this size. Alright, so first it randomly crops to any size and then resize it. So this is going to apply to all the apply to 128 by 128 images as well. So if we crop this to 128, if we crop the 128 by 128 images to any random size, it might lose most of the features. So that means we have to apply different transform. What does this minimum scale do? What if I tweak this? Let me check what has been said about this minimum scale. Minimum scale determines how much of the image to select at minimum. Okay, so we are just selecting 0.35%. What if I provide some more? So let's say 0.7%. So that might crop some more image. Let's get the data loaders now. Where was it? It's over here. Now let's try to train the model again. You can also use this type of transform. So resize, basically resizes all the images to 128 by 100, and because most of the images are 128 by 128 from this dataset, they won't be resized, I guess, and those that are not resized might be squished down to 128 by 128. So images from this dataset, if it gets squeezed, it might not look that much good. So it will give us this kind of images if they are squeezed. So it looks like it has improved a bit. Let's plot the confusion matrix for this model. So it is still not that much good, but we are still seeing we have improved, I guess, 0.001%. We are seeing this square and the square as well, which was not in the previous case. So now most of the zeros are classified correctly. Alright, so and zeros are basically it's just this fished. What about sixes? So sixes are, wait, sixes, most of the sixes are correct, but almost 3, 4 and 5, most of them are classified as 6 again, so that might be problem. Three, 4 and 5. So 3 is like this, 4 and 5 are classified as 6s. So does that mean, and also most of them are classified as 2s. So we are also seeing a straight line in the 2s column and 6s column. Most of the images are biased towards 6s and 2s. Let's plot the top losses. Alright, it is showing us 1 now as the top loss. Most of the ones are confused with 2, and this 5 is confused with 6, but 6 was like this. So this one, let's try to use a different transformation. So instead of using randomize resize crop, what if we use the squishing method? Let's see what kind of result it gives us. Let me copy this. And let's get the data loaders as well. Now let's check the batch. All right. Where are the thumb images? This images look all right, but you can see the thumb images. I wanted to check the thumb images specifically. There might be something we can do to check. So batch, there might be something in DLS which can show us the images. So let's see, DLS dot can check the train dot. I want to check the image where the category is 6. Well, this is 6, right? Or wait, is it 6 or something else? Yeah, it is 6. Clenched fist. So I want to check the images where it is 6. What can I do? Well, I can check this data set. This might contain the transform images, right? I hope so. So let's check dset. I want to check the transformed images. So training. Can I use where or something? Torch.where. Yeah, can use where. We can get the indexes. Indexes where dset.train.0 1 is equal to, let's say it should be 6. After getting the indexes, we can check dset.train indexes. Dset, sorry. Dset, it should be dset. What is it saying? No implementation found for tensor.equivalent. Why? We are choosing train 0, this 0, and out of that 1. Alright, I see why this is happening. What if I just select 6? Alright, this time it just gives us an empty. Let's check if we have something inside indexes or not. It's just an empty tensor. Why are we not getting the indexes? What does this gives us? An empty tensor. Why are we not getting this? Like, do we even have this class inside this dataset or not? Well, I'm just hoping that this random subset splitter gets the evenly distributed images according to the labels. So that so let's say reset a train.0. Just select the first element. I don't want to do that. I want to select an element where this tensor is 6. How can I do that? Well, torch.where reset a train. Okay, pass the reset the train, and I need to select this second element. Reset a train.0 only takes this first element out of this array or list. So what if I pass? I don't know. Maybe I can use ilock or something. Ilock. What does it gives us back? What about lock? Wait, I might have to use a parenthesis. Reset dot train 0. It gives us the first element. We need to compare these elements. How do I get the second element? What if I keep it empty and pass one more? Invalid, of course it is invalid. What if let's check this function's documentation. Torch.var. Select, let me check type of this. Data sets. Okay, so that might be why we can't use iLock and lock. It's not a numpy list or array. Well, let's not try to get this. Let's just train the model and see how it performs. So this were the kind of results we were getting previously. Let me train on the new data set now. Alright, while it is training, let me go and take a 2 minutes break. We'll be right back in 2 minutes. The model didn't improve that much. In fact, this time it started to get worse on the first epoch. After the first 0th epoch, it got worse. Let's plot a confusion matrix. Although this definitely don't look that much good. So we have figured that means a randomized resize crop works better than just resizing it. So that's that. Now after that we will try to use the precising method that might give us some good results. So in this case we will, let's see, we will use 128 resizing step, and after that we will use 64 augmentation transform. So we will do that in the next stream. Right now I gotta go for the lunch, so we'll see you guys in the next stream. We will continue from this point and onwards, and we will use this resizing step. Okay, then we'll see you guys in the next stream. Bye bye.